Well, welcome. I am Mr. Murphy, and in this particular video we're going to be looking at Power Standard skill number 21. And in this video we're going to be looking at how to simplify radical expressions. Now the way this is written here, just to interpret some things for you, we're going to be looking at the nth root of some numbers underneath the radical, and it's going to include some variables, but the roots for this standard aren't going to be any bigger than the third root. So that's what the n is less than or equal to 3 means, is that we're going to be looking at roots that are less than or equal to 3. Now what does that mean? What's our problems going to look like? Well, in a minute we're going to be looking at how to simplify problems like this and even problems like this one, like these here. But before we do that, it's important that we understand some things about roots and what is a root. So let's take a minute and look at these simple ones, like the square root of 81. The square root of 81 is going to be 9, because remember what a root is looking for is if it's a square root, we're looking for what same number multiplied by itself 2 times would give us that value. So for the square root of 81, I'm looking for what same number would I multiply by itself to get 81. Well, 9 times 9 is 81, so the square root of 81 is 9, which is pretty obvious, and you might know that already. But what about cubed roots? Like if I have the cubed root of 27, that means what times itself 3 times would give us 27? Well, 3 times 3 times 3 is 27, so the cubed root of 27 would be 3. Now this is not dividing, okay? You can't just take and divide and quickly get to an answer right away. It involves some thinking and some common sense as far as looking at, well, if I'm looking at a cubed root, number times itself 3 times, it's not going to be a very large number, it's going to be a small number. And if it's 27 that I'm looking at, it's not going to be 2, because 2 being multiplied by itself any number of times is always going to result in an even number. So just thinking about some things like that will help narrow it down as far as what are some potential numbers we should be looking at. Now, what if we're looking at a number like this one over here, the square root of 80? Because there is no integer that I can multiply times itself to get 80. Well, how would I simplify a problem like that? Well, to do something like that, we're going to do what's called a factor tree. So let's look to see how we can simplify the square root of 80. One way that we could approach this, like I said, is by using a factor tree. So we're going to look at any 2 numbers that would multiply together to give me 80. And you might see that 8 and 10 would work. Now I could use 4 and 20, I could use 2 and 40. Any multiples, as long as you're not using 1 and 80, would work here. So let's use 8 and 10. So 8 times 10 is 80, so 8 is not prime, so that needs to be factored down further. 8 breaks down to be 2 times 4. Now 2 is a prime number. Now what is a prime number? A prime number is a number whose factors are only 1 in itself. So 2 would only break down to be 1 times 2, which doesn't do us any good. So 2 is prime, so we're going to end with, or that 2, we're not going to do anything more with that. The 4 is not prime, so I need to continue to factor that down. 4 breaks down to be 2 times 2. And those are both prime numbers. 10 breaks down to be 2 times 5. And those are both prime numbers. Now if you notice I circle these prime numbers, again that helps me see that if I have a circled number, I'm done with it. It's a prime number. And so if I have any numbers left over that are not circled, I want to make sure that I factor those down as much as possible. Now this is a square root. Now if you think about what a square root means, it's a second root. So for every 2 of the same number, we get to factor 1 out. So if I have the square root of 80, what I have here, the 2 times 2 times 2 times 2 times 5, those are what we call the prime factors. If I were to multiply all those numbers together that I have circled, it would give me 80 as my answer. Now that's not what we're going to do here, but that would be a way that you could check to make sure that everything's going right so far. But again, since this is a square root, we're looking for pairs of numbers. So for every 2 of the same number, we would factor 1 out. So I would factor out a 2. I have another pair of 2's, so I would take out another 2. Now this 5 is still underneath the square root and doesn't have anything to pair up with it, so I can't factor it out, so it's going to stay under the radical. And the pair of 2's that we ended up factoring out, I'm going to multiply those together, so my answer here would be 4 square root of 5. So that's just one way that we could simplify if we have to simplify a root and it doesn't work out nicely using just basic integers. So we just did that with square root of 80. Let's look at the cube root of 56. So the cubed root of 56 is a cubed root. So we're looking for 3 of the same number. Well, there is no 3 of the same number that I can multiply to get 56, so I'm going to have to do a factor tree for this. So I'm looking for numbers that would multiply together to give me 56. Well, it's an even number, so I know if I don't know anything else, I know that 2 would work. And 2 times 28 would give me 56. And 2 is a prime number, so I'm going to circle that. Now 28 is not prime, that can factor down further. Now there's a couple of things that we could use. One of pair of numbers we could use is 4 times 7 is 28. And 7 is a prime number, so I'm going to circle that one. 4 is not a prime number, so I'm going to write this as 2 times 2. Now this is not a squared root, this is a cubed root, so this is going to be slightly different. So what I want to do for this one is I want to look for sets of 3. So for every set of 3 of the same number, I'm going to factor 1 out. So sure enough, I have a set of 3 2's. So I'm going to write this as 2 times a cubed root of 7. Now I want you to try one on your own here. Let's do the cubed root of 54. So I want you guys to take a minute and try this one on your own. So why don't you pause the video and hit play when you're ready to check your answer. Okay, so let's see what you should have done here. So 54, again, this could be factored down a couple different ways as far as 2 numbers that multiply together to be 54. Maybe you used 6 and 9. And 6 would break down to be 2 times 3, and 2 and 3 are both prime numbers. 9 is not prime, that breaks down to be 3 times 3. And again, since this is a cubed root, we're looking for every 3 of the same number to factor 1 out. So I have a set of 3 numbers here, a set of 3's actually. So I'm going to take out a 3, leaving me with the cubed root of 2 left over. And that would be the simplified form. Now let's make this a little bit more difficult. Let's say if we have some variables involved. Let's start with the 40. I'm going to break this down using my factor tree again. So this breaks down to be, let's use 5 times 8 is 40, and 5 is a prime number. 8 breaks down to be 2 times 4, and 2 is a prime number. And 4 breaks down to be 2 times 2. And it's a cubed root. So for every 3 of the same number, I'm going to factor 1 out, so I have a set of 3 2's. So the cubed root of 40 is going to simplify to be 2 times a cubed root of 5. But now I have these other items to deal with. I still have the cubed root of x to the 5th power, y to the 6th power. Now take a minute to think about what those mean. The x to the 5th power means that I would have 5 x's being multiplied by each other. And y to the 6th power would mean that I would have 6 y's being multiplied by each other. And just like when I'm doing a factor tree, for every 3 of the same number, I get to take 1 out. So I see that I have a set of 3 x's here, so I'm going to take out an x, leaving me with 2 x's under the radical. I see here that I have a set of 3 y's and another set of 3 y's. So I get to take out a y and another y, or a y squared, leaving me with no y's left under the radical. So a better way to write this, now we're going to piece all this together. I know this is kind of sloppy here, but we're going to put this all together now. And we're going to write, because remember we factored out a 2 here, so we're going to have a final answer that's going to have 2. And then we have an x, and then we're going to have the y squared. And underneath the cubed root, remember don't forget that cubed root there, we're going to have the 5 and the x squared. So that would be our final answer. Now a better way to do this piece that's not going to be as sloppy is to go back and look at what we had here. And we're going to use division. So remember back when you were dividing, we would see, well, how many times does 3 go into 5? Well, 3 goes into 5 one time. And what that would mean is that we're going to factor out 1x. And 3 goes into 5 one time with a remainder of 2, meaning that 2 are going to remain under the radical. 3 goes into 6 2 times evenly, so meaning I'm going to factor out 2 y's to be y squared. and there's none remaining, so there's not going to be any y's left over under the radical. So why don't you guys, if you can, why don't you take a minute and see if you can't simplify this other example. This is a square root this time, and we do have some variables underneath there. So you might be able to use that concept that I just talked about. It's a little simpler than doing what I boxed here in blue, than having to write that all out as 6 x's and 5 y's. So why don't you guys go ahead and see if you can't simplify that on your own. And so pause the video and hit play when you're ready to check to see if you have the right answer. Okay, so let's see how we did here. Again, this is a square root of 90, so I'm going to look at the factor tree here. Let's do 9 times 10. 9 breaks down to be 3 times 3, which are both prime. 10 breaks down to be 2 times 5, and those are both prime. So again, since this is a square root, for every 2 of the same number, I factor 1 out, so I'm going to factor out a 3. I'm going to give myself some space here because I'm going to have some other things I'll factor out. And underneath the radical, I'm going to have 2 times 5, which is just 10. Now let's go to my variables. Remember, this is a square root. Okay, if I need to erase some things to make some space here, I have a square root. So 2 goes into 6 3 times, meaning I'm going to take out 3 x's, or x cubed, leaving me with no x's under the radical. For the y, 2 goes into 5 2 times, because 2 times 2 is 4, but that leaves me with 1 y left over under the radical. So this would be your final answer. And you notice that doing it that way is a lot less sloppy than what we had with the previous example. So that's a better way to approach it. Well, there you have it. That is Power Standard Skill number 21. So hopefully you feel like you've mastered this and you can attempt some problems now on your own. So with that, good luck.